Okay, welcome to section 3. Okay, I know there's a little glare there. Okay, let me see if I can block it. Yeah, that glare right there. Chapter 6, section 3. This one we're going to see if we can determine whether a generic quadrilateral, four-sided figure, is indeed a parallelogram. Okay? There are 5 methods we can use to prove whether they are or not. Okay? Your resources for this. Okay? These 5 methods are listed on your chapter 6 notes, and it's page 7. Also, your notes, the PowerPoint, chapter 6, section 3. Okay? Let's go over these 5 methods. Now, these 5 methods you're going to look at and go, wait. These are very familiar. I just saw them yesterday. And you would be right. Okay? Because these are the converse, remember, changing the hypothesis and conclusion. Okay? These are the converse of the properties of parallelograms. So, we're going to trick the quadrilateral. We're going to check to see. And here's how we're going to do it. Okay? Each of these are if-thens. If both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. That is the definition of a parallelogram. Remember, if it's a parallelogram, then both sides are parallel. We're just flipping it around. Okay? If both pairs of opposite sides are congruent, if they have the same length, then the quadrilateral is a parallelogram. If the opposite angles are equal, then it's a parallelogram. If the diagonals bisect each other, remember bisect just means cut in half, okay? So if you got 2 equal parts on 2 different diagonals, you got yourself a parallelogram. And finally, if one pair, that's right, and it has to be the same pair, if one pair of opposite sides is both parallel and congruent, you got yourselves a parallelogram. Okay? That's it for the day. Let's move to the samples. I will be needing some colored pens. There we go. Okay, let's move. Okay, the extension cord is being persnickety today. I apologize. There's nothing worse than a persnickety cord. Okay, if you weren't dealing with a glare that's unbelievable here, you would be able to see that says determine whether each quadrilateral is a parallelogram. Okay, let's check. Okay, and we'll even put a reason on it. So on the first one, we have 2 equal parts of a diagonal, 2 equal parts of the other diagonal. We have the diagonals bisecting each other. So this is yes. Put a little note there for you. Okay. Look at number 2. We have a pair of opposite sides is parallel, but we only have one pair. Not enough information. Okay? This is the ever popular cannot be determined. Could it be a parallelogram? Sure. Okay? It can also be a flamingo, but we can't prove it. Cannot be determined. Okay, we've got a 4-sided figure, so we got a quadrilateral. Opposite angles are congruent. Okay, 118, 62, 62. Ooh, we got a yes. amazing how well we can abbreviate here. Next one. We have an opposite pair of sides that's parallel. We've got an opposite side of pairs that's congruent. However, they're not the same side. For that last method to work, they have to be the same side. Okay? Both parallel and congruent. So this is a cannot be determined. Okay? Okay. Let's move over to the number example. Okay? Now, once again, you can almost see this one. Find x and y so that the quadrilateral is a parallelogram. Well, that tells us that we have to use our properties here. Say, okay, for this to be a parallelogram, this has to be true. In this case, okay, I've got angles, so the only one I'm going to deal with is angles. And the one that I have is opposite angles are equal. Okay, so if opposite angles are equal, then it's a parallelogram. Let's find x to make that happen. There's the x's. Okay, let's go through our algebra real quick. 5x plus 29 has to equal 7x minus 11. Subtract 5x from 7x, you get 2x. Add 11 to 29, you get 40. Divide both sides by 2, you got 20. So x equals 20. Okay. Let's find the y's. 3y plus 15, 5y minus 9. And it looks like Mr. Blue Pen is about to disappear on me. Okay, so 3y plus 15 equals 5y minus 9. Okay, add 9 to both sides, subtract 3y from both sides, divide by 2. When y equals 12 and x equals 20, that is a parallelogram. Okay? And we're moving. Oh. This way. We got 2 more. Okay. And these are all the same type of problems, but they're making us use different properties. So on this particular one, okay, I have the diagonals. We know that in a parallelogram, diagonals bisect each other. We also know the converse says if the diagonals bisect each other, then it's a parallelogram. So that's what we're going to use. Those have to equal each other. Those have to equal each other. There's x and y on both. Okay? Doesn't matter which you start with. Okay? Subtract 2y from both sides. Add 5 to both sides. That's the easiest one we're going to deal with today. Okay? Now we do our x's. Okay? I'm going to bring the negative 4 that way to make it a positive x. Subtract 4 from both sides. You're probably thinking to yourself, wait a minute, I've got a negative number here. I can't have a negative length. And you would be correct. It's good to have those gut feelings sometimes. Okay? But what happened here? Negative 6. Let's plug that back in. Look, I've got a negative and a negative. So negative 4 times negative 6 gives me positive 24. That's where it comes out. Okay? So it does work. So when x is negative 6, when y is 13, we got ourselves a parallelogram. Okay? And finally, example number 7. We've got the sides. So in this case, opposite sides are congruent, then it's a parallelogram. So let's look at that. Negative 6x equals, okay? Negative 4x. Move that this way. Same situation, not a negative length, it's a negative value for a variable. Okay, and now we do the y's. Okay, subtract the 7y from both sides. Add the 7 to both sides. Okay. When y is 2 and x is negative 3, we've got ourselves a parallelogram. Okay? These are what your assignment is going to be dealing with on this section. Okay? Not difficult math again. Okay? There's really no difficult math throughout this section, to be honest with you. Next couple, we're going to be dealing with rectangles, rhombus, squares, trapezoids, kites. We're going to graph some of them. Okay? Graph's still up here, so we get to do that and look at various things. Okay? So that's what we're going to be dealing with. Okay? Enjoy. Good luck. Toodles.